Welcome to Lesson 510, Chapter 5, Lesson 10 for Math 6. Today we are doing just the opposite of what we did in Lesson 5-9. This time we are beginning with a fraction and turning it into a decimal. And in some ways this is easier because a fraction tells you what to do with itself. What do I mean by that? Well, what if I wanted to change the fraction 4/5 to a decimal? It tells you. Think of it this way. What if I changed the 4 to a dot, the 5 to a dot, and kept the fraction bar? What operation do I have? Yep, that's right. It's a division problem. A fraction is a division problem. In this case, 4 divided by 5. So that's what you do. 4 divided by 5. 5 would go on the outside. 4 would go on the inside. And then you're going till you either end the division problem, or as we'll see in our second set of concept, some decimals will continue on forever in a repeating pattern, and we'll deal with that momentarily. But in this case, here's my setup. 5 does not go into 4. 5 does go into 48 times. Multiply back. 8 times 5 is 40. There is no remainder. So 4/5 is 0.8 as a decimal. Pretty simple, but I'm going to have you try one right now. So why don't you try to change 3/5 to a decimal? So hit the pause button now. Okay, let's see how you did. 3/5 tells you what to do. It is 3 divided by 5. So that looks like this as a division problem. 5 does not go into 3. 5 does go into 36 times. Multiply back. 6 times 5 is 30. There's no remainder. So 3/5 is the same thing as 0.6. Pretty simple. That's the easiest of the problems changing a fraction to a decimal. Sometimes you might have to go a little bit further in your division work. What do I mean by that? What if I was changing 1/8 to a decimal? Again, it tells you what to do. 1 divided by 8. So your setup looks like this. 8 does not go into 1. 8 goes into 10 once. 1 times 8 is 8. Subtract. 10 minus 8 is 2. Bring down a 0. 8 goes into 20 twice. Multiply back. 2 times 8 is 16. 20 minus 16 is 4. I keep going until I have no remainder or I see a pattern. This problem is going to end because if I bring down another 0, 8 goes into 40 5 times. 5 times 8 is 40. Now there's that no remainder. So 1/8 is the same as 0.125. So sometimes you'll have to go to the tenths, to the hundredths, to the thousands, or even farther until it ends. Let's have you try a problem pretty similar to this. See how you do. So instead of 1/8, I'm going to have you do 3/8. So on your mark, get set, go, hit the pause button. All right, let's see how you did. 3/8 is 3 divided by 8. So your problem sets up this way. 8 doesn't go into 3. 8 will go into 33 times. 3 times 8 is 24. 30 minus 24 is 6, so I still have a remainder. Bring down another 0. 8 goes into 67 times. 7 times 8 is 56. Subtract. 60 minus 56 is 4. I still have a remainder. Bring down another 0. 8 goes into 45 times. Multiply back. 8 times 5 is 40. No remainder. So 3/8 is the same as 0.375. Fairly straightforward. It's just doing some simple division. But you may have the case where a number repeats in a pattern. It'll never end. but you'll see that there's a pattern developing, and that'll give you the, we'll go over the rules then about how to express that particular decimal. So let's try 5/6. I'm converting that into a decimal. Again, same thing, it tells me what to do, 5 divided by 6. So here's my setup. 6 doesn't go into 5. 6 does go into 50 8 times. 8 times 6 is 48. 50 minus 48 is 2, still a remainder, so I'll bring down a 0. 6 goes into 23 times. Multiply back, 18 times 6, or 3 times 6 is 18. 20 minus 18 is 2, still a remainder, so bring down another 0. 6 goes into 23 times. 3 times 6 is 18. 20 minus 18 is 2, there's still a remainder, bring down another 0. Can you see what's happening? 6 goes into 23 times. 3 times 6 is 18. 20 minus 18 is 2, bring down another 0. So the 3's are going to repeat forever. That's the pattern. So when I turn it into a decimal, I'm going to write out all my numbers, and then whatever number is the pattern, I'm only writing it as the pattern with a bar over it. So what the bar tells you is that this 3 goes on forever, just like it does here. So 0.833333333 is abbreviated this way. So why don't you try one? And I'm just going to change one thing. Let's change it to 1/6. So hit the pause button on your mark, get set, go. All right, let's see how you did. 1 divided by 6. 6 doesn't go into 1, but it does go into 10 once. 1 times 6 is 6. Subtract 10 minus 6 is 4. Bring down a 0. 6 goes into 40 6 times. 6 times 6 is 36. 40 minus 36 is 4. You're probably already seeing what's happening if you did when you were working it out. Remainder, so bring down another 0. 6 goes into 40 6 times. 6 times 6 is 36. 40 minus 36 is 4. Bring down another 0. 6 goes into 40 6 times. Multiply back. 4, bring down another 0. So it's the 6 that keeps repeating. So it's the 6 that's going to get the bar because that's the pattern. So it's going to be 0.1 and a 6 with the bar over the 6 because that tells you it's the 6 that keeps repeating in a pattern. Only one more kind to look at with repeating, because sometimes the pattern might be more than one number repeating in a pattern. What do I mean by that? Well, let's look at this example. 3/11. If I want to convert that. 3/11 is 3 divided by 11. So here's my setup. 11 doesn't go into 3, but it does go into 30 twice. 2 times 11 is 22. 30 minus 22 is 8. I have a remainder, so I bring down a 0. 11 goes into 87 times. 7 times 11 is 77. 80 minus 77 is 3. I have a remainder, so bring down another 0. 11 goes into 30 twice. 2 times 11 is 22. 30 minus 22 is 8. I have a remainder, bring down another 0. 11 goes into 87 times. 7 times 11 is 77. 80 minus 77 is 3. Bring down another. So can you see the pattern? It's going to be 27, 27, 27, 27, 27, and never end. So how do I write that as a decimal, non-terminating decimal? 0 point. And then since it's the 2 and the 7 that repeats forever, the bar goes over both of them. The bar tells you that it's the 2 and the 7 that keeps repeating in a pattern. Okay, I'm going to give you 1 and see how you do with that. And I'm going to throw in one more kind of twist to this one, just so we can cover 2 ideas in the same problem. This time I'm going to ask you to do 1.5 or 1 5/11. Turn that into a decimal. It's going to repeat forever in a pattern, but I've made it a mixed number now. And so the only thing that you have to remember is that this is a whole number. Remember, it's to the left of the decimal. So my answer is going to be 1 point, whatever the 5/11ths turns out to be. So that's the way you're going to record your answer. So we're only looking at doing this part, the fraction, as a decimal. The 1 is already a part of the answer to the left of the decimal point. So I'm doing 5 divided by 11, and I'm going to let you finish it out. So hit the pause button now. Okay, welcome back. Let's finish it out. 11 doesn't go into 5. I don't need the 0 there really because I already know there's going to be a 1 here. So 11 goes into 50 4 times. 4 times 11 is 44. 50 minus 44 is 6. I have a remainder, bring down a 0. 11 goes into 65 times. 5 times 11 is 55. 60 minus 55 is 5. I have a remainder, bring another 0 down. 11 goes into 54 times, and you're starting to see, or you saw what went on. 4 times 11 is 44. 50 minus 44 is 6, bring down a 0. 11 goes into 65 times. 5 times 11 is 55, subtract, bring down another 0. So it repeats in the pattern 4, 5, 4, 5. The 4, 5 repeats. So that means my final answer is the 1 from the whole number. And then since it's the 4, 5 that repeats in a pattern, the bar goes over both of those. And there you go. So that concludes Chapter 5, Lesson 10.